Hello, everybody. This lesson is on algorithms. So, first of all, I know the first thing is, well, what the heck's an algorithm? It's not a term that's used regularly by people, most people anyway. And so you might not even have heard it before. Or if you've heard it, you may not know what it means. But we're going to talk about it for for a few minutes here as an aid to help you through the remainder of this class. Let's go ahead and get into the little deck here. So we're going to, first of all, we're going to do our introduction as always. We're going to talk about what an algorithm is, why it's important, or why are they important, and how are they created. And we'll get into our conclusion and final tips and homework as it mentions in there as well. So we're going to try to keep this relatively short because it's not a terribly difficult concept, but it is something that many of you may not have thought about much. So let's get into it. So, as you know, I like to always talk about at the beginning of a lesson, what it is that we hope to have happen out of this lesson. So, out of this lesson, we want you students to be able to develop a simple algorithm in English that has sufficient detail that the algorithm can be given to someone else and that person could successfully complete the task by following the algorithm. Pretty straightforward there. There's no 70% on this one. People need to be able to follow the algorithm. You need to be able to follow the algorithm. So, on the other hand, the standard's somewhat high. Anyway, so what is an algorithm? So whenever I'm asked for the meaning of a particular word, I typically, if I have time, like to go look at a dictionary. Not because I don't know what the word means, but because sometimes there's alternative definitions. There's things that I might like to provide. So when I realized we were going to be talking about algorithms, and I was writing my slide deck for this, the first thing I thought about is, well, I need to have a decent definition of what an algorithm is. And so I looked in the Merriam Webster online dictionary, and this is what I found: a procedure for solving a mathematical problem as of finding the greatest common divisor in a finite number of steps that frequently involves repetition of an operation. Ton of words in that, and really I didn't want a ton of words. I wanted something that's pretty straightforward. However, when I continued to read, I found this next piece, which is, you might consider it maybe a summary that they had underneath that longer statement that said broadly a step-by-step procedure for solving a problem or accomplishing some end. I like this a lot better than the other one, simply because, first of all, the way they stated it sounds like algorithms only happen in science and math and computers. That's not the case at all. The algorithms are around us all the time, and because we're not familiar with that term, we may not even realize what we are working with is an algorithm. But okay, so I guess the second question that occurs to me as I'm going through this is, well, why do we call it an algorithm anyway? They said, well, because if you see down here, it's kind of like step by step procedure. Well, aren't all procedures kind of step by step? Don't they all solve problems or accomplish some end? So why don't we just call it a procedure? Well, the only real good answer I can think about it is, we're scientists. We got to have some special word for it. So algorithms it is. All right. Uh, so we're going to go through some example algorithms that you've seen. So one of the reasons I liked, before I move on, one of the reasons I liked that second definition was to kind of get it out of the realm of science, and to show that yes, in fact, this is something that's useful beyond programming and science and computers and math. In reality, like I said, they're around us all the time, and so I'm going to provide you some examples. So first of these I got from the governmental arm that was used to be called the Immigration and Naturalization Service and now goes by the acronym ICE, which stands for Immigration Customs Enforcement. And that's what ICE stands for. They don't say whether that's a service or an agency or whatever, but the essence of it is okay. So this is on their website. And clearly, from the definition, you can see that one of the things as part of the U.S. immigration process is getting a visa. And we see that the immigrant visa process has 12 steps. And okay, that's good so far. So one of the first things I want you to get out of this is that all the algorithms have to have two qualities. So cuts out two qualities. One of them is the steps. The other is the sequence. Those are both important. The steps without the sequence can lead you astray and lead you into, actually creating a worse situation than not having the steps at all. Anyway, now you can say that the sequence here is clearly implied because it's labeled 1 through 12. And generally runs left to right across the top and then goes down and then kind of reverses the process. And we have further visual clues with those little carrots that are between the different blocks. Okay. But, I point out to another example that I'm not going to show you, but I talked to a recipe, right? So you don't frequently, at least in my experience, you don't always see step 1, do this, step 2, do that. What you see is the implied Western standard of top to bottom, left to right. So when you think about a recipe as an algorithm for making some dish, whatever that dish happens to be, it is those step-by-step procedures in a particular sequence, a finite number of steps in a particular sequence that get your result. In this case, hopefully something yummy to eat. Well, one thing before we move on here, though, is, and this will be very relevant to the next part we're going to talk about, is some of these steps are really, wow, they're pretty high level. And I don't necessarily know by looking at this what these things mean. So we see that we have, for instance, financial documents. That's the one I pick on all the time when I look at this is, okay, what are financial documents? How many are there? Where do I get those? Who completes them? How do I get them to the ICE? All of those kinds of things. And then as you look through this, I would say that almost every one of these probably requires a little bit more explanation in order to actually develop out a list of things I need to do. So that's going to be very important as we continue on in talking about, kind of the next piece of this. We're still kind of defining and providing examples of algorithms, but we got to talk a little bit about how algorithms are developed or made. So anyway, here's another example, and this is closer to what we're talking about. You'll notice that, the area top that I've circled in red has got 5 steps. These are the 5 steps I need to do to accomplish this program. And I can tell you, and there's probably several of you in here that have enough familiarity with language that it's very easy to map between the steps that are listed and what's actually written in the program. I'm not going to spend any time on that here, and you're not going to be writing code. You're going to be doing all of this in English. So, one of the things I kind of wanted to get into was, well, why are we even talking about algorithms? Well, there's 2 major reasons. One of them is much of computer science is the study of algorithms. It's the development of new algorithms to accomplish particular things, but more commonly these days it is evaluating the different types of algorithms that you have and what they're good for and what their performance characteristics are like and when you use them, when you don't use them, all sorts of things about the algorithms there. Now, algorithms are separate from code, so And that's one of the bigger things that happens as you go through all of this is you learn that code is just a way of expressing an algorithm. So you'll want to have the algorithm first. So why are they important? Well, I'm sorry. Second reason. Second reason that I wanted to talk about that we wanted to talk to you about algorithms is simply this. We've noticed in prior classes that when we get to the programming part, some people will be completely overwhelmed to the point where they get what I call the deer in the headlight look. They just don't know what to do. They're stuck. They don't know whether to run left, run right, run forward, run backwards. They have no idea where to go, what to do. And in talking with a few of them, I would ask them, well, what's wrong? And what I would hear would be things like, I don't know what to do. I don't know where to go. I understand what you said in the lesson, but it doesn't tell me how I get started. And so talking about algorithms and developing algorithms is hopefully going to give all of you that opportunity to begin to develop that mindset of how do I break a problem down and to a point where I know what to do? How do I take that problem and begin to develop a plan for how I'm going to program to solve that problem? So that's why we're having this particular lesson. So are they important? As I say, our recipe is important. If you don't follow the recipe very well, you're likely to have unusual results, right? So this is kind of one of the things that you want to do is if you've done your thinking up front, you've done your planning up front, then actually the process of applying the code, well, it requires some skill and certainly some thought and some effort, and you're going to make some mistakes, and you're going to find the mistakes, you're going to correct the mistakes. All of that will happen, but it'll happen a lot faster if you have an algorithm to begin with. If you will, it is starting a hike with your trip mapped out already. In other words, you've marked on the map where you're going to go and all of that kind of stuff, because you can follow your progress along the map and you'll be able to confirm that you're on the right track all the way along the way. So these analogies are very similar to why we're suggesting that it would be good for you to learn how to do algorithms. And in fact, what we're going to encourage you to do is before you start doing programming, before you start doing any programming of any kind at all, particularly in the projects we're going to give you, write your algorithm down. In fact, I'm going to require it because I'm going to want to see the algorithm as well. So we need to know how to build algorithms. So again, the point here is that algorithms specify not only what needs to be done in the order in which they need to be done, but they're also that process of identifying the steps of the algorithm and thinking it through is going to reveal that that when you're going to need additional information on what decisions need to be made. And those become critical things. So let's get on to the next one, because I have something very critical to kind of get into. So when we begin coding, which I think begins next week, for some of you the programs are going to seem to be really overwhelming, and it's going to be a lot easier if you've broken it down into manageable steps. Now the process for breaking it down was something that used to be in the curriculum decades ago when I started in this business. When I started in computer science, it was part of the curriculum. It was typically taught in classes like pseudocode or flowcharting or whatever. And you're going to find out, but the process itself has been called stepwise refinement. And if you just think through what those words are, you can probably get a pretty good hint on what it is. Now, the funny thing to note is the process for developing an algorithm is itself an algorithm. So let's take a look at it. So, stepwise refinement. 3 steps. Break the problem statement into major tasks. Might be 3, might be 12, but break it into major tasks. Again, so if you look at the INS thing, they have 12 major tasks. They've broken it out that you've got to get accomplished. Like in there, though, each of those tasks may not have, stating the task may not be enough information. So you got to think about, what is it that I need to accomplish that task? What things am I going to do? What information do I need? And I'm going to repeat this again. And I would often give this to people that were struggling. I said, look, all computer programs are going to have at least three major steps. And it's pretty simple when you think about it. First of all, you've got to get some kind of input. You're getting some data from somewhere, whether it's from another computer or another program, or you're getting it from a sensor, or you're getting it from a human being. You're going to get some information from somewhere. And then you're going to do some uh, value added processing. In other words, you're going to change it in some form or fashion. You're going to be looking for particular information to come out of that, conclusions you can reach based on the information that was gathered, or how much money we made, all of those kinds of things, right? That's that processing. But coming to those results without getting them to people that actually can use them is kind of useless. So you've got that third step. You've got to be able to reveal the results. So you got to be able to get the information, you got to process the information, and you got to produce the results. Those three things. So, as a minimum, when you start through the stepwise refinement, you already know three big steps. Get the input, process the data, and reveal the results. Okay? That's simple. Now, again, like the ICE thing, there's a lot of detail in each of those steps. So then what do you do? Well, for each of those steps, you break them down into pieces. You break it down into further tasks, subtasks, actually. So you start with major tasks, then you start to break those into subtasks, and then you go back through, and it becomes what we call an iterative or recursive process, where you keep kind of going back and doing the same thing over and over and over again until you get to some point at which you realize you're done. And you do this over and over again. You keep breaking each task or subtask or sub-subtask or sub-sub-subtask down further until at some point you know how to solve this problem. You've got all the detail you need. And then you move, and once you've done that, you've moved on. And all of those, that final layer of subtasks is actually your map to how you're going to get things done. Because you've detailed, this is the first thing I need to do, and this is the next thing, and this is the next thing, and this is the next thing. And each one of those things you know how to do. So then you just do them in the programming language in a way that you know how to do it. And I can guarantee you that the projects that we're going to have you do are very simple from my perspective and from anyone that's coded anything. They are very, very much very basic things. They will only seem strange and difficult because you're not accustomed to looking at them. And by building out this plan, it should make it a lot easier for you. So here's an example of an algorithm that's kind of real world, doesn't have anything to do with computers. And again, I'm going to emphasize, at least during this part, we're not going to ask you to do any coding. When I ask you for an algorithm, I do not want you to give it to me in code. I want you to give it to me in English. There are more formal ways of doing it. There's something called pseudocode out there. There's lots of pseudocodes out there. But the essence of it is, English is fine. I don't have to have any kind of formalism in there. I just need you to express what you're going to do and the order in which you're going to do it. Okay, cool. So here's an example. Here's a simple one many people can relate to, and it's simple enough that everybody can understand it for sure. This is near and dear to my heart. About a year ago, my wife and I, we love Jack Russell Terriers, and we've had one now for 8 years. She's in her little middle age, and she's starting to slow down a bit. We wanted her to continue to have a fun, happy life, but she's hanging out with a couple old people, and so I don't know how much fun that can be. So we decided to go get another Jack Russell Terrier. We got a boy this time, and a little bit over a year ago. And if you get a dog, a puppy, he was 4 months old about that time. When you get a dog or a puppy, one of the things you have to do is you have to really start to consider things like potty training them. First thing, it's probably the first thing you need to think about. All right, so I'm sure everybody knows that, right? But many people, if you've never raised a dog, don't know what that process is. So we're going to talk about that. So what I did was I thought about what that process is, and I broke it really into 4 steps, 4 major steps. One of them is get the puppy. The second is watch the puppy closely. And the third is take it outdoors when it needs to go. And then it's a reward. That's how you train puppies and dogs in general, is by positive reinforcement. When they do what you want them to do, when they understand you reward them, they will quickly come to terms with the idea that, oh, this is what he wants me to do. And, oh, by the way, I get a treat, or I get a hug, or I get a brush, or whatever it is that works for them. Anyway, so that's a simple thing. But notice in here, I already kind of gave you a hint, right? So as I'm going through this, and I'm sure many of you thought of this, is how am I going to watch that puppy closely all day, every day? Is there a switch where I turn them off so I can get some sleep or eat or go to the bathroom or whatever? And the short answer is no, there is no switch. They'll go to sleep when they want to go to sleep, and they'll wake up when they want to wake up. So, okay, so what do we do about that? So we think about it a little bit further. I realize now, as the algorithm developer, I need to come up with a little bit more information. So I say, okay, I'm not messing with step 1 yet. Step 2, okay, I need to, so I need to clarify. So when you're awake, keep the puppy with you, but when you're asleep, put the puppy in its crate. Why? Because puppies, like humans, do not want to poop or pee where they sleep. It's not any fun, so they don't do it. And so if they're in their crate and they're all curled up in their little bed in there, and then they get the urge, they're not going to do it there. So they're either going to hold it, or at some point, if they're starting to get really urgent, they're going to make it known. So there's another requirement in there. Well, I need to be within earshot of the crate, so I can't have it across the house or in the garage or outdoors. I need to be able to hear the dog, so it needs to probably be in the bedroom. So notice the steps 3 and 4 don't change, but again, notice I've already had another thought. Does the puppy have a crate? We didn't specify that so far. When do we need to have the crate? Well, probably before we need to get the puppy, or at least at the same time we get the puppy. And certainly we need to have that crate as part of training. So somewhere before we actually start watching the puppy, we need to have done something about that crate. And so here we go. We see that what I did was I went back to step 1 and broke it into substrates. Like, okay, part of getting a puppy is you got to get the crate, and you got to get the puppy treats for rewards. It's another thing that came out of that whole process. So you get the general idea. Obviously, we haven't gone very deep into this, and there's a lot more we could do here if we wanted to. And the essence of developing algorithms is you do enough that you know what you need to do. And for me, this is enough. Of course, I've puppy trained many dogs, or potty trained many dogs. So it's enough for me. But if you asked me to do it, it would be a much longer algorithm. If you asked me for that, whatever that process was, it would be a much longer algorithm. So this is kind of a general idea this is a conceptual idea of how stepwise refinement goes. You see where you start with the problem, you break it into sub-steps. Each of those you take a look at and determine if there are further sub-steps that needed, and so on and so on and so on, as I said before. So I'm going to give you a more to the point example. And in fact, we're going to see this example several times, because as we go through and learn things about programming, we're going to see how that impacts the algorithm. And we're going to write that into our algorithm. Or you're going to write it into your algorithm. So as we introduce these different things throughout the programming part, I'm going to show you how the algorithm changes, and hopefully this will make things for you a lot easier for all of you. So anyway, I started. Sitting there thinking, well, what's something simple I could do? And average came up to mind because I think almost everyone knows how to do an average, right? You you take a bunch of numbers, you sum them together, and then you divide by the number of numbers, and that gives you your average. And I forget what that's. I think that's your median, not your whatever. For those of you who are heavy into math, excuse me. I'm even though I've taken a lot of math in my life, I'm not a mathematician. So anyway, you get so to make this simple. Let's start with the basic. What I want. So what we've got here is a project statement or program statement. It says this is what the stakeholder wants. They want a program that calculates the average of any three integer numbers. And so I sit down and think, okay, well, I kind of know what the general algorithm for getting an average is. So I'm going to get the three numbers and I'm going to add them together. And then I'm going to divide that sum by three. Okay. And that's probably something I need to fix on this. It should be divide the sum of the three numbers by three. But you get it. You get it. So, all right. So clearly it's not quite enough information there. I need to have a little bit more information in there. When I think about it, is okay, where am I going to get the information from? And what and how do I keep track of those numbers? How do I keep track of those three numbers? On and on and on. So if you will, the second iteration in here, we see that I broke step one into two sub-steps. So ask for the first number, write it down on paper. Second number, write it down below the first number on the same piece of paper. Third, below the second number on the same piece of paper. Add the column together. Label the result as S. Why? Well, because again, and I didn't make it very clear in the last slide, well, you're actually not dividing the three numbers, you're dividing the sum of the three numbers. So that was what S means, it's the sum. And then I'm going to label the result A. Not really necessary to do that yet, but it's good practice because this is going to come into play almost immediately. I guarantee you we'll probably be talking about it next week. All right. That's how you would do it towards, actually writing a program. So what you need to understand is that almost any problem can be solved by using this technique. Solving the problem in English is a form of pseudocoding, as I said before. You're not using the actual programming language itself. You're not constrained by syntax or anything like that. You are somewhat constrained by logical kinds of things that we'll talk about later. But the essence of it is that you can express it in English. You can express it top to bottom, left to right. And, and as you kind of go through the process of stepwise refinement, to, you'll be able to you'll be able to do that. You've got a tool now for developing that plan. And once you've got the plan, the programming projects will be almost as easy as I say they are. So remember, the objective was for you to be able to develop out algorithms that could be used by other people to accomplish the task. And so let's talk a little bit. Let's talk a little bit about homework. So this homework statement is actually in D2L, and that's where you would refer to it and upload your results. But essentially, I want you to write an algorithm for something you're familiar with that maybe others aren't, or maybe it is. I don't know. I don't really care one way or the other. What I want you to do is I want you to write down an algorithm. I want you to get used to thinking about things in terms of what are the steps to accomplish that task and what's the order of the steps to accomplish that task. And then provide enough detail in there that someone else could do it based on what you've written down. In fact, that'd be a good test. Give it to your roommate or best friend or mom or dad or whoever, significant other. Give it to whoever and see, okay, could you do this? and see what they tell you. And that's great feedback. You'll learn a lot by that process. I would suggest, if you really want to have a fun one, is try to think about the algorithm for tying a shoe. When you get into that, we all do that, right? We do it every day probably, or at least most days. We tie a shoe. We know how to do it, and we've done it, a gazillion times, and we don't even think about it. So you stop and think about what the steps are, and then you try to describe them in detail to someone who's never tied their shoes before. They never tied a pair of shoes before in their life. Say, you've got someone that was with one of these tribes down in South America that's been, primitive forever back in the Stone Age, and for some reason one decides to move into high modern society, and one of the first things you got to do is help them understand how to tie a shoe. So think through that. Anyway, so I don't want you to spend a lot of time on this. Take as much time as you need, but not a lot of time. So try to put a limit on it. I'm hoping to see somewhere between 5 and 15 total steps, and that includes sub steps and everything else. So, should be able to fit on a single piece of paper, all of that good stuff. I don't want you to spend a ton of time on it, but I do want you to come with the grips of the idea that, hey, I'm going to have to start breaking problems down into their steps and making sure that the sequence of the steps is clear once it gets executed. So thank you all for listening. I hope you get something out of this, and I'll look forward to seeing you at the next class.